In this lecture, we will take a look at some more functions that are available in Terraform. We have used a few Terraform functions throughout this course, most notably the file function to read data from a file. We have also used the length to determine the number of elements in a given list or a map. We also had a look at the toSet function, which we use to convert a list into a set. And although we have used functions before, we have done so by using it within configuration files without seeing what the functions do specifically and how it transforms and combines values that are provided to it. Fortunately, Terraform provides an interactive console that can be used for testing functions as well as interpolations. To get into this interactive console, we use the command terraform console. The interactive console loads the state associated with the configuration directory by default, allowing us to load any values that is currently stored in it. It also loads variables that are stored within configuration files. This allows us to experiment with functions and interpolations that can later be made use of within the configuration files. For example, we can test the file function in the console like this, and it should return the contents of the main.tf file. Using the length function shows that the number of elements in the list variable called region is 3. And finally, we can see that the toSet function converts the same variable from a list to a set and removes the duplicates. Remember that a set cannot have duplicate values, so during this transformation, the toSet function removes the duplicate value of US East 1, which is present in the list variable twice. Besides these three functions, there are dozens of other useful built-in functions available in Terraform. We will take a look at some of the commonly used ones next. There are several categories of functions available in Terraform. However, in this course, we will only take a look at some of the commonly used ones, specifically ones belonging to numeric functions, string functions, collection functions, and type conversion functions. Numeric functions, as the name suggests, is used to transform and manipulate numbers. For example, we can make use of the max function to return the greatest number from a set of numbers. The min function does the reverse and returns the smallest number. To use variables as arguments for a function, we have to use a slightly different syntax. For example, consider a block for a variable called num, like this. To use this variable with the min or the max function, the values inside the set can be expanded into separate arguments. This is done by using the expansion symbol by making use of 3 periods or full stops like this. Some other commonly used numeric functions are the ceil and the floor functions. The ceil function rounds to the closest whole number that is greater than or equal to the current argument. For example, ceil of 10.1 will return the value of 11, same as ceil 10.9, as 11 is the closest whole number that is greater than either of these two floating numbers. Floor does the opposite and returns the closest whole number that is lesser than or equal to the argument that is provided. Let us now look at some of the string functions. These functions are used to transform or manipulate string type data. The first one that we are going to look at is the split function. This function is used to transform a string to a list of elements by making use of a separator. The syntax to do this is the split function followed by a separator and a string enclosed within brackets. Again, this can be tested using the Terraform console. Notice that the string that we have used here has a few dummy AMI IDs that are separated by a comma. To split the string to a list containing 3 elements, we can use the split function with the separator, which is comma, and the complete string, like this. Notice that the output is a list now. Just like before, let's also make use of a variable and test this function. Here, we have a variable called AMI with the same string. Passing in the variables as the second argument to this function, comma being the first, we get the same result as before. Notice that the variable called AMI, there's a text that is all in uppercase. To convert the string to use only lowercase, we can make use of the lower function like this. And to do the opposite and change it all to uppercase letters, use the function called upper. To just convert the first letter of each word in a string, use the tile function like this. The substring function is used to extract a substring from a string, or in other words, cut a string into a smaller string by providing an offset and a length. The offset defines the index of the character after which we want to cut the string. For example, to cut from the very first character of the string, we must provide the offset as 0. To cut from the second character, use the offset of 1, and so on and so forth. The length defines the number of characters from the offset to cut and convert to a substring. Excluding the commas, the length of a AMI ID in this example variable is 7. As such, we can create substrings using the length of 7. The offset can be 0, 8, or 16. The join function does the opposite of split. It converts a list to a string by adding them all together. Let's now take a look at collection functions, which are used for collection data types such as a set, list, and map. We have already seen one example in this category, which is the length function that we use to determine the number of elements in a list. To find the index of a matching element, we can make use of the index function. For example, to find the index or location of the element called AMI-ABC in the AMI variable, we can make use of the index function like this. This function takes two arguments. The first is the list, and the second is the value of the element for which we want to find the index. In this example, the element AMI-ABC is located at index 1. Remember that the index of a list always starts at 0. To find an element in a list located at a specific index, we can make use of the element function like this. Here, the element located at index 2 is the AMI ID called AMI-EFG. To check if a specific element is present in a list or not, use the contains function like this. This function will return a value of true or false. In the first example, the element AMI-ABC, all uppercases, is present in the list and hence returns a value of true. In the second example, the element AMI-XYZ, all in uppercases, returns a value of false, as such an element is not present in the list. This is despite the fact that the same value with all lowercases is still present in the list. To wrap up this lecture, let's have a look at some functions used for map data types. Here, we have updated the AMI variable, which is now a map. This map uses region as a key and an associated AMI ID as the value. To convert this map to a list with just the keys, we can make use of the keys function and supply the map as an argument like this. To convert it to a list with just values, which are AMI IDs in this example, use the values function. Finally, to look up the value of a specific key in a map, we can make use of the lookup function like this. This function takes two arguments, the map and the key for which we want to look up the value. If the key provided to this function is not available in the map, this will result in an error. However, optionally we can pass in a third argument to this function. This is the default value that will be returned if the key provided in the argument does not exist in the map, like this. In this case, the lookup function will return the value of AMI-PQR, even though the key called USWest2 does not exist within the map. And this is because this value has been supplied to the function as a default.